Alright, so we're going to be looking at graphing the function f of theta is sine theta. And as we do this work, everything goes back to our unit circle. So let's just remember that our unit circle starts here at 0. And we're going to be looking at the unit circle in radians, not in degrees. So we go counterclockwise. We're at pi over 2, pi, 3 pi over 2, and then back over here to 2 pi. So the circumference of a circle is 2 pi radians. 2 pi radians for the unit circle, since the radius is 1. Remember that any ordered pair around the circle is the ordered pair xy, and that is cosine theta, sine theta. So our x value is our cosine value, and our y value is our sine value. And so as we graph these functions, we want to start by making a table. This table will have one column for theta and one column for the sine of theta. And the key values for theta that we're going to use are 0, pi over 2, pi, 3 pi over 2, and then 2 pi. So when we start here, an angle of 0 radians is right here. The y value is sine, so the y value is 0. Then we're going to go around the circle. At pi over 2, our y value is 1. At pi, which is over here, the y value is 0. 3 pi over 2 is here, so that y value is negative 1. And then 2 pi is back around to the end of the circle, and that's 0. Alright, so now we're going to, in essence, roll out our x-axis, our independent axis. It's really our theta axis. And I'm going to mark off pi over 2, and pi, and 3 pi over 2, and 2 pi. Then on my y-axis, I mark off 1 and negative 1, because I can see from my table that that's as high as I need to go. And then I'm going to go through and plot these ordered pairs. So we're going through the point 0, 0. And then at pi over 2, our output is 1. And when we input pi, we output a 0. When we input 3 pi over 2 for the angle measurement, the output is negative 1 for sine. And when we put in a 2 pi for our angle, our sine is 0. Now, this graph it's not a zigzag graph. It doesn't make V-shapes. It's a wave. I mean, we could plot a lot of the points in between and see that wave, but just kind of trust me on this one. So the sine curve comes like this, and comes back up. So at no point, nowhere is it going to come to a sharp point. It's a wave. It's like a hill and a valley. Now, this is not the end of the sine curve. What we have done is we have graphed one cycle of the sine curve, right? So this has taken us one lap around the unit circle. And so now we want to look at the characteristics of this graph. So we're going to start with domain and range. The domain for all sine and cosine graphs is going to be all real numbers, negative infinity to infinity. Because this graph is continuous, it doesn't have any asymptotes, keeps going to the right. Likewise, it comes over here, it keeps going to the left. Now the range does have some limits. The lowest value is -1, and the highest value is +1. And we're using brackets because those values are included. The graph touches 1, the graph touches -1. Alright, so we're going to look, where does our graph begin and end a cycle? So it begins at 0, ends at 2 pi. So that means that the period of this graph is equal to 2 pi. So 2 pi is a linear length, and every 2 pi the graph repeats this little wave. Hill and valley, hill and valley. Alright, we want to talk about our x-intercepts. Just in this one cycle, it crosses the x-axis 3 times. Here we have 0, 0, pi 0, 2 pi 0. Where's it going to hit again? Three pi, right? And again at 4 pi. You see that every multiple of pi, it's going to cross the x-axis? So our x-intercept is pi times n. And n can be any integer. Alright, so let's talk about this z right here. Z is the set of integers. And what does that set look like? I'm going to put 3 dots, ellipses, -2, -1, 0, 1, 2, and then 3 more dots. The set of integers is infinite, so I can't write it all out. But the set of integers is the set of whole numbers and their opposites. So the set of integers includes positive numbers and negative numbers, but they're whole numbers and their opposites. There's no 1.5 or 2.7. There's no 1/2 or 3/4. It's whole numbers and their opposites. So my x-intercepts are at 0, pi times 1, pi times 2, pi times 3. It would be over here at -1 times pi, -2 times pi. Those are all my x-intercepts. Alright, now let's look at the range. The range is related to the amplitude. And so to find the amplitude, you take your maximum minus your minimum and divide by 2. So in this case, my maximum is 1 and my minimum is -1. 1 take away -1 is 2. 2 divided by 2 would be 1. Let me zoom out a bit. So the amplitude can be seen right here. Amplitude. It's a vertical measurement. My period is a horizontal measurement from here to here. This is the period. 2 pi. This is my amplitude, which is 1. Alright, so let's talk about what the max and the min values are and where they occur, right? So there's a maximum. The maximum output is 1. But where does that happen? That happens at pi over 2. And then, is this graph ever going to reach 1 again? It is, right? If it keeps doing the wave. Let's go ahead and think about where some of these other points are. Let's basically take another lap around our unit circle. So, I would put this down here, but I ran out of space, so I'm just going to continue my table here. Theta, sine theta. If I go all the way around the unit circle once, and then I go to make a second loop, right? This is 2 pi, which is equal to 4 pi over 2. So when I come up here, I'm at 5 pi over 2. Right? So what I'm saying is I went all the way around the circle, plus another pi over 2. I'm at 5 pi over 2. And my sine is going to be 1. And then when I go over here, that's going to be 6 pi over 2. But 6 pi over 2 is the same thing as 3 pi. And my sine is 0. And then when I come down here, I'm going to be at 7 pi over 2. And my sine is negative 1. And then when I come over here, I'm going to be at 8 pi over 2. 8 pi over 2 is really 4 pi. And I'm going to be at 0 again. So if I continue my graph, here at 5 pi over 2, I'm at 1. And then at 3 pi, I'm at 0. And then at 7 pi over 2, I'm at negative 1. And then over here at 4 pi. So I've got another cycle of my graph. Oh, do you guys, I did something not right here. Wasn't counting. Do you see that I put positive 1 up 2 spaces and I put negative 1 up 3 spaces? I should not have done that. Negative 1 should be here. Sorry about that. So I'm going to use colors. So you can see we did one period of our function. And then we have a second period of our function. And then the wave's just going to keep on doing like that. So it's going to be at its maximum at pi over 2, and then again at 5 pi over 2. So what's the difference from pi over 2 over to 5 pi over 2? How far apart are those two guys? Do you see that they are 2 pi apart? Think about it on your unit circle. If you're here and your sine is 1, and then you've got to go all the way around the circle until you get to 1 again. And then all the way around the circle and you get to 1 again. And all the way around the circle and you get to 1 again. So the maximum happens at pi over 2, and then every 2 pi. So 2 pi times n. And again, n is going to be an element of the integers. Alright, so what about our minimum? Our minimum is going to be at negative 1. And that's going to happen multiple times also. The first time it's going to happen is at 3 pi over 2. And then it's going to keep happening every 2 pi. Plus 2 pi n, where n is an element of the integers. Alright, so there is everything about your sine theta graph. If you have any questions about that, type them in the chat or turn on your microphone and ask. so now together we're going to do two other graphs that have transformations. All right, they're both going to be sine graphs. And as we graph these, in your mind you want to be comparing to this parent function. How is what we're doing like? F of theta equals sine theta. How is it different? How is it the same? How is it different? That's what you want to be thinking about. All right, so the first one we're going to do, we're going to do f of x equals 3 sine x. Now, this x could be x, this x could be theta, right? You're going to see your variables. Some books will use an x, some books will use a theta because you are measuring an angle. So I wanted to switch on purpose so that you'd get used to both. So the way we're going to start, step one is always going to be to build a table. But in this case, our table is going to have 3 columns. Well, we're not using theta, we're using x right now, aren't we? So if I were going to evaluate this function, right, I would take an angle measurement and plug it in for x. And the first thing I would do is I would calculate sine of x. And then after I calculated sine of x, I would multiply by 3. So that's why I have my table set up like this. So we're going to put in our regular 5 points. 0, pi over 2, pi, 3 pi over 2, and 2 pi. So again, we're thinking about our unit circle. So sine of 0 is 0. Sine at pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. And sine of 2 pi is 0. Alright, now I don't know about everybody on Zoom, but I have some people in my class that are not writing. This is one of your, no, actually this one is, and I lied. But the other one and the one we do next is part of your homework. So if you work along with me, you'll have it partially done. So now I'm going to multiply 3 by this value. So 3 times 0 is 0, 3 times 1 is 3, 3 times 0 is 0, 3 times negative 1 is negative 3, and 3 times 0 is 0. So now when I go to plot my points, right, this is my input, and this is my output. So, did I complete a whole sine wave? I started at 0, went to positive, went to 0, went to negative, went back to 0. So I completed a whole sine wave. So I'm ready to set up my graph. Oh, but look, I have to go all the way up to 3. And down to negative 3. My x-axis, I'm still going to mark pi over 2, pi, 3 pi over 2, and 2 pi. So I went through 0, 0. At pi over 2, my graph goes all the way up to 3. At pi, I'm at 0. 3 pi over 2, I'm down to negative 3. And at 2 pi, I'm back to 0. So what happened compared to our parent function sine theta? What effect did this 3 have on the graph?
The amplitude increased. Oh, sorry.
Go ahead, say that.
The amplitude increased.
Okay, so we changed the amplitude. What else?
The minimum and maximum.
Very good. The minimum and the maximum changed. How might you describe what happened? A vertical stretch.
Vertical stretch.
Yes. So right here, this 3 caused a vertical stretch by a factor of 3. So I'm going to go through some parts really quickly. The domain didn't change, negative infinity to infinity. The x-intercepts, those didn't change. Those happen every pi times n. Right? The period didn't change. It's still 2 pi. We still begin at 0 and end at 2 pi. Beginning and end. Same. All that's the same. So what did change? The range changed. It went from negative 3 to positive 3. Right? So I'm going to put everything that changed, I'm going to highlight it in yellow. So the range changed. Our min and our max, those changed. Those are now negative 3 and 3. But where they happened is the same, right? That's happening at, well, my minimum is at 3 pi over 2 plus 2 pi n, and my maximum is at pi over 2 plus 2 pi n. So where they're happening did not change, but what they are changed, because it was a vertical stretch. And then the amplitude changes. So the amplitude is now going from negative 3 up to positive 3. That's 6. 6 divided by 2 is 3. The amplitude is 3. So that was a change. So again, here's my amplitude. So whenever we have a number multiplied by our function, that's going to cause vertical changes, right? If this number is greater than 0, it's going to be a vertical stretch, and your max is going to go higher, your min is going to go lower, your amplitude's going to increase. If this number is less than 1, that's going to cause a vertical compression. Your max is going to go lower, your min is going to go lower in value, be higher on the graph, and your amplitude is going to decrease. Right? Alright. Let's do one more together. Now we're going to look at g of theta equals sine of 1/2 theta. So this time I'm going to use the theta. I want you guys getting used to whether you see theta or x, that your brain just kind of can roll with both of those. So I'm switching them up on purpose. So this time when I make my table, because that's what we want to start with, I have my values for theta. And then what am I going to do to theta? I have to multiply theta by 1/2 first. So I take 1/2 theta, and then after I take 1/2 theta, then I do the sine. So in terms of order of operations, I do this step first, and then I do sine second. So that's why I'm going to set my table up like this. So I'm going to start with 0, pi over 2, 3 pi over 2, and 2 pi. I'm going to draw me a little unit circle over here. I can see what's going on. Alright, so 0 times 1/2. Let me pause. I know you guys still need that. Alright, so 0 times 1/2 is 0. Now, if I multiply pi over 2 times a half, I'm multiplying the denominators together. That's going to be pi over 4. So then when I multiply a half times 3 pi over 2, again, I'm multiplying the denominators together. That would be 3 pi over 4. And then if I do 2 pi times a half, well, half of 2 pi is 1 pi. Oh,
Miss Coyle, you're
thank you.
missing pi. Oh, sorry.
Thank you so much. I am missing pi. Thank you for catching that. So when I do pi times 1/2, I get pi over 2. Thank you, thank you. So now let me take the sine of each of these. So the sine of 0 is 0. All right, remember where pi over 4 is. Pi over 4 is 45 degrees. It's right here. The sine at pi over 4 is positive square root of 2 over 2, and that is approximately 0.7. All right, then my sine at pi over 2 is 1. 3 pi over 4 is here in the second quadrant. In the second quadrant, sine is positive, so that's positive square root of 2 over 2. Again, which is approximately 0.7. And then at pi, right here, the sine is 0. All right, now think about a sine, right? It's a wave, right? The sine always starts at 0 and it goes up and makes a hill and then a valley, but I didn't even go into the negatives yet. Do you see on my unit circle, I've only gone halfway around the unit circle. So I need more entries here. So I'm going to keep counting by pi over 2. So if I'm at 2 pi and I go another pi over 2, that's 5 pi over 2. And then if I go another pi over 2, that's 6 pi over 2, which is equivalent to 3 pi. And then another pi over 2 is 7 pi over 2. And then another pi over 2 is 8 pi over 2, which is 4 pi. So if you're real good at simplifying these fractions in your head, thank your 3rd, 4th, 5th, 6th grade teacher, because that's coming in really handy. That's all I'm doing, right? I'm just simplifying fractions. Alright, so if I'm at 5 pi over 2 and I multiply it by a half, again, I'm multiplying my denominators. That's 5 pi over 4. 3 pi times a half, 3 pi over 2. 7 pi over 2 times a half, 7 pi over 4. 4 pi times a half, 2 pi. So now I'm going to take the sine of each of these. Well, in my unit circle, where is 5 pi over 4? It's right here, right? In the 3rd quadrant. In the 3rd quadrant, sine is negative. So that's negative square root of 2 over 2. Do you see why we learned the unit circle first? So that's approximately negative 0.7. 3 pi over 2 is here. Sine of 3 pi over 2 is negative 1. 7 pi over 4 is here in the 4th quadrant. In the 4th quadrant, sine is negative. That's negative square root of 2 over 2, approximately negative 0.7. And then 2 pi is back here, sine is 0. Alright, but now look at what we're graphing. We're graphing theta as our input, and sine 1/2 theta is our output. So when I go to draw my graph, right, so don't draw your graph until after you do your table. My x-axis has to go all the way out to 4 pi. Pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, 4 pi. Oh my goodness, my line is so crooked. That's terrible. Y'all make yours neater. Alright, my y-axis, I'm looking at my values. The highest number I see is 1. The lowest number I see is negative 1. So I'm only going to go up to 1 and down to negative 1. And then I'm going to plot points. 0, 0. Pi over 2 is 0.7, about there. Pi, where was I at? I had to squeeze pi in there. Pi is 1. 3 pi over 2 was 0.7 also. Then at 2 pi, my sign was 0. 5 pi over 2, I'm at negative 0.7. 3 pi, I'm at negative 1. 7 pi over 2, I'm at negative 0.7. And then at 4 pi, I'm back to 0. There's my sine wave, my sine curve. So think about comparing this to plain old sine theta, the parent function. What changed? What stayed the same? What effect did that 1/2 have on the graph? Type some things in the chat, guys. What's happening? What's staying the same? What's changing? What's the 1/2 doing to the graph? Let me see what's going on in the chat. We're getting some answers. Alright, very good. So this is causing a horizontal stretch. Right? We're doing a horizontal stretch by a factor of 2. And it's changing the period. Right? Everybody sees that very clearly, that our period now, we are beginning here and ending here. And so our period is 4 pi. And the period of the regular sine function is 2 pi. So 4 pi is 2 pi multiplied by 2. Right? It's not a coincidence. That's what happened there. So in this case, everything that's horizontal changed. So did our x-intercepts change? Yes. Our x-intercepts changed. But did our max and min or our amplitude change? No. So max, min, amplitude, this is all the same as sine theta. Range is going to be the same. But our period is changing. Our x-intercepts are changing. Now, even though our max and min aren't changing, where the max and min happen is changing, right? So instead of the max happening at pi over 2, now the max is happening at pi. Alright, now, some of your other functions, guys, so if this is a 1/2 right here, and this is causing this horizontal stretch, what's going to happen if I put a positive number in here, like a 6? So if I have something like sine of 6 theta, that's going to be a horizontal shrink or a horizontal compression. So that means that's going to take this and it's going to crunch it 6 times. So you know what that's going to mean? you're going to have to put smaller numbers in here for theta. Right? Because you're going to have to think ahead, because you've got to get a whole cycle through. So hint, when you get to one that's 6, right, think about doing pi over 12 as your marker. Hint. It's a hint for you.